Hello, sixth graders. So yesterday we were talking about integers. And now integer, the definition of an integer is a counting number. So 1, 2, 3, 4, 5, and so on. Its opposite, so the negative of that, and 0. All right? And integers do not include fractions or decimals or percents. All right? So that's where rational numbers come in, and that's what we're going to be talking about today. Okay, now this is actually supposed to be topic 3-2. By accident, I wrote topic 2-2. So we're going to be graphing rational numbers. Now, a rational number is basically any number that can be turned into a fraction. Okay, so half is a rational number. The number 3 is a rational number because you can put it over a 1 to make it a fraction. So a rational number is any number that can be turned into a fraction. And we're going to be graphing these rational numbers. So in order to graph a rational number, you're going to be dealing with fractions and decimals and whole numbers. So basically, you need to know the the decimal and fraction equivalents. So that's why we have this little chart here. Okay, if you look at the fraction half, you can see that fraction half is lined up with the decimal 5/10. So half is equivalent to the decimal 5/10. If you look at 3/4, we have 1/4, 2/4, 3/4. That lines up with 75/100. So the equivalent for 3/4 is 75/100. So you can find a lot of equivalents for these. If you look at 2/8 here, and you see what that lines up with, 2/8 lines up with 25/100. So you can easily find your decimal and fraction equivalents using this chart. And this is going to be really handy when we're graphing rational numbers on a number line. So always resort back to this chart to help you find equivalents. So let's look at our next slide. It says, when identifying where a point is on a number line, count how many blank there are in between each whole number. So yesterday when we were graphing a line or points on a number line, we were just counting by ones. What we're going to be doing today is we're going to be seeing where the number is in between each whole number, okay? So each whole number is going to be broken up into spaces, okay? So if you're identifying where a point is on a number line, count how many spaces there are in between each whole number. So if there are 5 spaces, then each whole number, okay, each number is broken into fifths. If there are 10 spaces, each whole number is broken into tenths. Okay, so we're dealing with parts of a whole today. So let's look at this number line. I see 0 is right here. Okay, I see 1 is here, 2 is here. Those are the positives, and then we have the negatives on the other side. All right, so let's look. If I look in between 0 and 1, how many spaces do you see between 0 and 1? Well, I see 1, 2, 3, 4. 4 spaces. So this number line is broken into fourths. Okay, so we have 0, we have 1/4, we have 2/4, 3/4, 4/4, which is equal to 1. And you can go the opposite way. We have 0, negative 1/4, negative 2/4, negative 3/4, and negative 4/4 or 1. Okay, so each number is broken into fourths. We can easily see that because there are 4 sections. All right, so let's look at the letter A. That's our first one. A is right here. A, I see, is between -3 and -4. And we talked about this yesterday, that the farther away the number is from 0, the smaller it is if it's a negative. Okay, and again, what I said yesterday as well is that you always want to start at 0 when determining these. It makes it a lot easier. So we have 0, -1, -2, -3, and then we're going to continue to -4 by counting those dashes. So we have negative 3 and, if this is fourths, the first fourth is negative 3 and 1/4, negative 3 and 2/4, negative 3 and 3/4, and then negative 3 and 4/4, or negative 4. So A is equal to negative 3 and 1/4. B, I see, is right here. If we start at negative 4 and 1/4, negative 4 and 2/4 is B, and negative 4 and 2/4 is the same thing as saying half. Okay, C is right here. Okay, we have 1 is here, so the next available fourth is 1 and 1/4. D is right here. Okay, so we can start at negative 5 if you want to start at 0 if you want to, but negative 5 is going towards negative 6, so it's negative 5 and 1/4, negative 5 and 2/4, negative 5 and 3/4. Okay, we have E over here. We kind of counted that earlier. We have 0, then we have 1/4 and 2/4 is E. 2/4 is the same thing as half. And lastly, we have, oh, I wrote D again. Whoops. I think I meant to write F. So you can delete that and write an F instead. Okay. F is right here. We have negative 2, and we're counting towards negative 3. So we have negative 2 and 1/4, negative 2 and 2/4, which is the same thing, negative 2 and a half. All right. So the big thing you want to just make sure is that your count, first of all, you want to make sure that each number is broken into the correct amount. If you have 4 spaces, it's in fourths. If you have 5 spaces, it's in fifths. If each number is broken in 10 spaces, you're counting by tenths. Okay. So let's look at another example. So we just talked about identifying points in the number line and writing them down, the rational numbers. Now we're going to be graphing points on the number line. So when plotting points on a number line, look at the fraction or decimal to decide how you have to break up each whole number. So for example, if all the fractions are in eighths, you know you want to break up. If this is 1 and this is 2, you know when you want to break up each whole number into eighths. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. If it's 3/4 and 1/4, you know you want to break up each whole number into fourths. 1, 2, 3, 4. Okay, so it just depends how you have to break it up. Now, if the number line is already drawn, like we see down below, make sure to convert every decimal into a fraction in order to plot it easier, okay? Again, that's just a recommendation from me to convert every decimal into a fraction because it's a lot easier to look at a number line and graph fractions than it is to graph decimals. So first we need to see, we're looking at this number line right here, okay? And I see 0, I see 1, and I see negative 1. How many spaces are between 0 and 1? There's 4 spaces. So I know I'm counting by fourths for all of these. All right, so let me erase this real quick. So the first thing we're going to do is look at all of these values, and we're going to convert them all into fractions. So 3/4 is already a fraction. 25 hundredths. What is that equivalent in fraction form? Think about quarters. If you're not sure either, you can look at this graph. Let me erase this real quick. You can look at this graph and see that 25 hundredths is right here. What is equivalent to that in fourths? If we draw a line, it's 1/4. So 25 hundredths is the same as saying 1/4. Okay, 1 and 5 tenths. What is an equivalent to 1 and 5 tenths as a fraction? Again, 5/10 is right here. If we draw a line, it's 1 2/4. So this is the same as saying 1 2/4. Negative 1/4 is already a fraction. Negative 75/100ths, again, 75/100ths if you're not sure what that is. Now, these decimal and fraction equivalents should be easier to remember as we do this, but right now you're allowed to use this graph if you want. Find 75/100ths, go down to where it matches with fourths, and you see it's 1 2 3/4 is equal to 75/100ths. So it's negative 3/4, and then we just have -1. So let's graph these values on this number line below. So let's start with 3/4. 3/4 on this number line, we see 0. Well, this first dot would be 1/4. This next dash would be 2/4. This next dash right underneath is 3/4. 25/100ths, or which is 1/4. You can write 25/100ths, but again, I like making them a fraction because it's easier to plot on the graph, on the number line. We have 0. The first dash is 1/4. So you can put 25/100ths there, which is the same as 1/4. The next one, 1 5/10 is 1 2/4. That's its equivalent. So we have the number 1, we have 1/4, and then we have 2/4, 1 2/4. So this is 1 5/10, which is the same as 1 2/4. Okay, then we have negative 1/4. We start at 0. Again, I always like to start at 0, and then we go towards the negatives. So this is negative 1/4. The next one is negative 75/100ths. Again, it's a negative, so we're going to go this way. We can start at 0, and it's the same thing as saying negative 3/4. So we have negative 1/4, negative 2/4, negative 3/4. And lastly, we have -1, which is right here. All right. So again, I would recommend writing the fraction equivalents to each decimal so it's easier to plot on your number line. And again, when you're plotting these, always start at 0 and then either count up or count down toward the negative numbers to see where each value goes. So this whole lesson was all about rational numbers. And again, a rational number is any number that can be turned into a fraction. So all of these numbers here are rational numbers because they are all fractions. And even if they're a regular integer, this -1 can be turned into a fraction by putting it over a 1. So they can all be turned into fractions, meaning that they are all rational numbers. So attached to this Edpuzzle is going to be a Google form that has you plotting things and that has you identifying where certain points are on the number line. So what I would suggest, again, always use this to help you understand where certain points are on the number line and help you get certain decimal and fraction equivalents. All right. Let me know if you do have any questions and have a wonderful day. Bye.